Want to know if Aurora 44 is a better distro than Fedora? Stay in the video to find out and see the performance test results. In this video, we will install, review, and evaluate Aurora 44. From the website, we download the image with NVIDIA drivers. We boot the image and wait for the system to start, but it did not boot and showed errors indicating that no boot device was found. We went back to the website to investigate, and in the download section there is a recommendation to use Fedora Image Writer. So we entered Plasma's Discover, searched for Fedora Image Writer and downloaded it. Then we burned the image to the USB drive. We boot again. Now it enters the KDE Plasma desktop. But when running the installer, it does not start and shows an error. We make the third boot attempt. It enters the desktop environment, but when running the installer, it hangs while initializing. We try for a fourth time. Now we modify the boot to use basic graphics mode. It enters, but still does not run the installer. We try for a fifth time, leaving the normal boot. As before, it enters, but running the installer gives a UDEF-Q error. Clearly, NVIDIA drivers do not allow installation due to incompatibilities. We download the Intel version and burn the image again. We boot again. It enters the environment, and for this image, running the installer works and shows the welcome message. It asks us for the language. Select your preference, then the keyboard layout you use, and we enter date, time, and country. Now we select the disk, also the installation method. In my case, I select Erase Disk, then Next, and Erase and Install. Aurora was created by Universal Blue. This organization is also in charge of developing Bazzite and Bluefin, all based on Fedora. The system boots for the first time and the speed was slow. We wait for the desktop environment to load and it asks for setup. It asks us to enter the language, keyboard, layout, name, user, password, and confirmation, then the PC name and network. It finishes the configuration and asks for the password to enter the system. It shows the usual desktop welcome screen. We review the desktop panel and menu. The applications are the default ones. In general, the environment looks adequate. Now we open the terminal and increase the font size to improve visibility. We also expand the size of the application window. We install the Fastfetch and Sysbench packages with Brew installed to observe system information and perform benchmark testing. We run Fastfetch and see that the kernel version is recent memory usage at idle and megabytes per package are average. Now, we execute commands to review the information, considering the distribution version, the kernel, and memory usage. Then, we check the space consumed on the disk. Now we verify the boot time minus the firmware time, which is relatively slow. We run Sysbench to evaluate performance, starting with the CPU in a single thread. The result in events per second is excellent. We run the CPU test with 5 threads to check concurrency management. A very good result is obtained from this operation. We test the threads directly with Sysbench to evaluate how the system handles concurrency. The result obtained was average. Now we evaluate mutexes to see the efficiency of lock handling using 5 threads. The comparative result was average. We test memory reading to evaluate its management. The result obtained is excellent compared to other Linux distributions. Now we test memory writing to evaluate the speed at which data is written. The result obtained from this test is good. We prepare the files for a disk input and output test. This indicates an average sequential write speed on the system. We run the test indicating that the mode will be random read and write. The final read and write result is very low. We run the top command to see memory usage. Then we run Firefox to load a web page in the window without extensions. Now we open a second tab, but this time we load a video with this. We want to measure average memory usage per active tab. We open a third and a fourth tab. Then we calculate the average memory consumed per tab. The final result is very high. We run NVIDIA SMI, but since we are using an Intel image, the drivers will not be installed. First, we must install RPM Fusion. One downside of using RPM OS3 is that installation takes longer. Remember that Aurora is immutable. At the end, we must reboot. Upon entering, we open the terminal and run RPM OS3 install Acomod NVIDIA 58XX. With this, we install the NVIDIA drivers. Again, we must restart the system for it to take effect. After entering the password, we open the terminal again. We check NVIDIA SMI and it failed. We check if Nouveau is still loaded, and yes, we must run RPM OS3 cargs to blacklist it. We reboot upon entering. We open the terminal and check again if the Nouveau module is loaded. Not now. NVIDIA SMI works fine. Now we install the GL Mark II package to test graphics performance after installation, and as usual we reboot the PC. We run GL Mark II and it uses the default card for rendering, which is the Intel card. Build measures driver and GPU capability. Ideas. This test renders abstract and logical scenes. Terrain renders a large 3D terrain with complex geometry for testing. Refract. This test simulates the refraction of light through transparent surfaces. The score obtained by Intel was excellent. We run GL Mark II with environment variables, offload and vendor to render with NVIDIA. Bump simulates relief through bump mapping. With the jellyfish test, many moving semi-transparent objects are rendered. Shadow evaluates dynamic shadow projection. Loop evaluates loop efficiency inside shaders. We wait for it to finish. The NVIDIA card score was very good. We open Firefox to run the Basemark Web 3.0 test with the Intel card. This test evaluates browser graphics performance. It evaluates performance in web applications, intensive graphics and frameworks like jQuery and Angular. It tests DOM and CSS. It also compares results with other systems and verifies browser compatibility. The score for the Intel card was excellent. With env variables, we run Firefox using NVIDIA. Basemark Web 3.0 is used on PCs and mobile devices running intensive JavaScript. It examines browser behavior, intensive graphics with WebGL 2.0, frameworks like jQuery and Angular, plus DOM and CSS evaluations. It compares results with other computers and verifies the browser compatibility level. The NVIDIA result was very good. We have finished the evaluation of Aurora. We turn off the system as we will present the final conclusion based on several aspects. In conclusion, Aurora 44, unlike Bazzite, which is oriented toward gaming, can be seen as a distribution closer to Fedora. This includes incompatibilities with NVIDIA drivers. The overall performance, just like Bazzite, is lower than Fedora. This is all for this video. If you liked it, subscribe, leave a like, and activate notifications. See you in the next one.